The National Electrical Code, specifically Section 250.24 of FIV, addresses neutral conductor bonding requirements, especially concerning the avoidance of parallel paths for neutral current. This section is crucial for ensuring electrical safety and proper system operation. Section 250.24 FIV focuses on situations where a grounding electrode conductor is not installed. In such cases, the bonding connection between the neutral conductor and the equipment grounding conductor must be made at the service entrance, and only at the service entrance. This requirement is in place to prevent undesirable and potentially dangerous parallel neutral current pathways. The service entrance is the point where electrical power enters a building or structure. It typically includes the service disconnect, overcurrent protection, and the point where the neutral is bonded to ground. The key principle here is to establish a single point for neutral to ground bonding. When the neutral is bonded to ground at multiple locations, it creates parallel paths for neutral current to flow back to the source. This can lead to several problems. Firstly, increased current flow on metallic parts of the electrical system. When neutral current flows through unintended paths such as metal conduits, enclosures, or other metallic structures, it can cause these parts to become energized. This poses a shock hazard to anyone who comes into contact with them. Secondly, electromagnetic interference, or EMI. Parallel neutral currents can generate electromagnetic fields that interfere with sensitive electronic equipment, causing malfunctions or data errors. Thirdly, inaccurate readings from ground fault protection devices. Ground fault circuit interrupters, or GFCIs, and ground fault protection of equipment, or GFP, devices rely on detecting imbalances in current flow between the hot conductor and the neutral conductor. Parallel neutral paths can reduce the sensitivity of these devices, making them less effective in detecting and interrupting ground faults. Fourthly, overheating of metallic components. Excessive current flow through unintended metallic paths can cause these components to overheat, potentially leading to insulation damage or even fire. The code specifically prohibits bonding the neutral at the distribution panel in a detached building, such as a bungalow, when the main service disconnect is located elsewhere, like at an all-in-one meter base and disconnect. If the neutral is already bonded at the service disconnect, bonding it again at the house panel would create a parallel neutral path through the grounding conductors and any interconnected metallic systems. To correctly implement 250.24 FIV, firstly, identify the service entrance. Locate the main service disconnect where the electrical service enters the building. This is usually where the meter is located. Secondly, ensure neutral bonding at the service entrance. Verify that the neutral conductor is properly bonded to the equipment grounding conductor at the service entrance. This is typically accomplished using a bonding jumper or screw provided by the equipment manufacturer. Thirdly, verify no neutral bonding at the distribution panel. At the distribution panel in the bungalow, ensure that the neutral conductor is isolated from the panel enclosure and the equipment grounding conductors. Remove any bonding jumpers or screws that might be connecting the neutral to ground at this location. Fourthly, maintain a separate equipment grounding conductor. Ensure that a dedicated equipment grounding conductor is run from the service entrance to the distribution panel in the bungalow. This conductor provides a low impedance path for fault current to flow back to the source, facilitating the operation of overcurrent protection devices. Fifthly, use proper wiring methods. Use approved wiring methods, such as non-metallic conduits or cable with an insulated grounding conductor, to ensure that the equipment grounding conductor remains isolated from other metallic components. If metallic conduit is used, ensure that it is properly bonded to the equipment grounding conductor at both ends. The intent of 250.24 FIV is to ensure that the neutral current returns to the source through a dedicated neutral conductor, minimizing the risk of stray currents and ensuring the proper operation of safety devices. By adhering to this code requirement, electrical systems are safer, more reliable, and less susceptible to interference. When an inspector requests bonding of the neutral in an existing panel, it is essential to verify the entire electrical system configuration. Check if the neutral is already bonded at the service entrance. If it is, bonding it again at the panel would violate 250.24 FIV. In this case, the appropriate action is to show the inspector the existing bonding at the service entrance and explain that additional bonding at the panel would create a parallel neutral path, which is not permitted by code. If the inspector still insists on bonding the neutral at the panel, firstly, request a written explanation. Politely ask the inspector to provide a written explanation of why they believe bonding the neutral at the panel is necessary, citing specific code references. Secondly, consult with a qualified electrical engineer. If you are unsure about the inspector's interpretation of the code, consult with a qualified electrical engineer or another experienced electrician for a second opinion. Thirdly, appeal the decision if necessary. If you believe the inspector's decision is incorrect, you may have the option to appeal it to a higher authority such as the local electrical board or a state licensing agency. Always maintain detailed records of all inspections, communications, and actions taken to address any code violations or discrepancies. This documentation can be helpful if you need to appeal a decision or defend your work in the future. Understanding and correctly applying 250.24 FIV is essential for ensuring the safety and proper operation of electrical systems. By following the code requirements and best practices, electricians can prevent dangerous parallel neutral paths and create electrical installations that are safe, reliable, and compliant. Furthermore, it's crucial to understand the definitions of service entrance, grounded conductor, and equipment grounding conductor as they relate to the NEC. The service entrance is the point where power is supplied to a building. The grounded conductor, typically the neutral, carries current back to the source. The equipment grounding conductor provides a path for fault current to return to the source, minimizing shock hazards. Bonding these components correctly at the service entrance is paramount. In summary, neutral bonding should occur only at the service entrance when a grounding electrode conductor is not installed, according to NEC section 250.24 FIV. This prevents parallel neutral paths, which can lead to safety hazards and equipment malfunction. Always verify the existing system configuration and consult with qualified professionals if there are any discrepancies or uncertainties during inspections.